So today we're going to talk about solving a quadratic by factoring. And we're going to be using our techniques from Factor Master to solve by factoring. But first of all, what we have at the beginning of our notes is a picture of a quadratic. It is this U-shaped curve, also sometimes known as a parabola. The quadratic y equals x squared minus 2x minus 3 is graphed. And what we want to know is, what are the x-intercepts of this quadratic? What are the x-intercepts here from this picture? Really? -1. Is there anything else? And also 3. -1 and 3. Remember that x-intercepts are where the graph crosses the x-axis. And x-intercepts in a quadratic are also known as solutions, zeros, and in fact also roots. And we can find x-intercepts of a quadratic by using what's called the zero product law and factoring. And our zero product law is listed here. It says if the product of multiple factors is equal to 0, then at least one of the factors must be equal to 0. Well, the words make more sense when we look at an example. What we have in problem 2 is it says solve each of the following equations for all values of x. Well, the nice part is that they're already factored. So what the zero product law says is that we can take each factor and we can set it equal to 0. So we're going to take x plus 7, set it equal to 0. We're going to take x minus 3 and set it equal to 0. And then we can subtract 7 from both sides. And we get x equals -7. We can add 3 both sides. We get x equals 3. The zero product law says that either x equals -7 or x equals 3, or they both solve that equation. At least one of them solves it. Same thing over here on letter B. Either this factor equals 0, or this factor equals 0, or they both equal 0. That's what the zero product law says. 2x minus 5 equals 0, or x minus 4 equals 0, or they both do. So if we add 5 to both sides, we get 2x equals 5. Divide both sides by 2. Over here, for the x minus 4 equals 0, if we add 4 to both sides, we get x equals 4. Had to pause for a minute, but once again what we did is we set 2x minus 5 equal to 0, we set x minus 4 equal to 0, and then we solved both of those equations to get our x-intercepts of this quadratic function. But most of the time what we have to do here is that we do have to factor. It says, let's look back at the quadratic from problem 1. And the quadratic from problem number 1 says y equals x squared minus 2x minus 3. Let's factor the quadratic. So we're going to factor it. And when we factor, remember that the number in front of the x squared is a 1. We're going to multiply a times c. 1 times 3 is 3. And the good news is that the only factors of 3 are 1 and 3. And will 1 and 3 ever combine to be 2? Yep. What do our signs have to be? Because we have to combine to be -2. positive 1 and negative 3. So when we go back in here, let's do plus 1x minus 3x. And now what we've done is we've created a grouping problem. And what's our GCF in our first group? Well, it's x, the smallest exponent. And we're left with x plus 1. Remember, we had two x's. We took out 1. We've got 1 left. 1x divided by x is 1. Over here in our second group, the GCF, Tiffany, is 3. When we factor it out, 3x divided by 3 is x. Negative 3 divided by negative 3 is positive 1. And now we can come up with our roots, with our x-intercepts, with our solutions. X plus 1 is in both groups. Remember, we only write it down once. And then we have x minus 3, our singles. Originally, the problem was equal to y, but let's set it equal to 0, so we can use our zero product law. And what we do is we take x plus 1 and set it equal to 0. We take x minus 3 and set it equal to 0. And some of you probably don't need to do that step. You probably can go from x plus 1 equal to 0 to x equals negative 1. And x minus 3 equals 0 to x equals 3. And when you're comparing, if you look back up there at our picture of our quadratic and our values, sure enough, they are the same. Negative 1, positive 3. So that problem at least gets us a little bit into factoring again. We don't want to lose that skill here. It says, solve each of the following quadratic equations. Leave answers in simplest fraction form if necessary. And what we're going to have to do on this method here, 3a, is the same thing that we had to do on the bottom of our front page there, is we're going to have to split the middle. So we're going to start with our a times c, 2 times 24, which is 48. And the factors of 48 are 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. Will any of those combine to be 13? Really? 3 and 16. Jordan, do you know what the signs are going to be on these?
Negative 3 plus 16.
Negative 3 plus 16. So when we come over here, we'll write down 2x squared. And we'll write down the 24. And then, do you want to put 3 first, or do you want to put 16 first? And it doesn't matter to me. 3 first. And it doesn't matter. If you put the 16 first, you should end up with the same factors as I do in the end. They might be in a different order, but they'll be the same factors. So what's the GCF in our first group? Well, there's only an x. 2x squared divided by x is 2x. 3x divided by x is 3. By the way, we had 2 x's from the 2x squared. We took out 1. We have 1 left. Over here in our second group, the biggest number that goes into both 16 and 24 is 8. And we get 2x. 16x divided by 8 is 2x. 24 divided by 8 is 3. And sure enough, we have the same factors in each group. We have a 2x minus 3. So we're going to write that value down once. And then we have an x plus 8. And today, Instead of just factoring, we need to solve our quadratic, and that's going to require us to take each factor and set it equal to 0. 2x minus 3 equal to 0. X plus 8 equal to 0. Well, when we solve, we'll add 3 to both sides. And we get 2x equals 3. Divide both sides by 2. Over here, subtract the 8 from both sides. So a good review of factoring, and then we're adding one more step. Same thing. We need to solve this quadratic equation by factoring. Well, our A in this problem is 1. Our C in this problem is 9. 1 times 9 is 9. And the factors of 9 are 1 times 9 and 3 times 3. Well, will either of those combine to be 6? Simply? You even gave me the sign. -3 and -3. So we've got our x squared. And we've got our 9. Minus 3x. Minus 3x. And then we're going to group. We've got 4 terms. Now, when we have 4 terms, we factor by grouping. So, what's in common in the first group? Jordan? It's x. We had 2 x's. We took out 1. 3x divided by x is 3. Over here in the second group, what's the biggest number that goes into both 3 and 9? 3. 3x divided by 3 is x. 9 divided by -3 is -3. And the nice part here is that we have the same factors in each group. We only want to write them down once. But we have an x minus 3 here and an x minus 3 there. And then our singles also end up to be x minus 3. So we have the same factors. And then we're going to get x minus 3 equals 0. X minus 3 equals 0. So we can add 3 to both sides. And we get x equals 3. And notice, if we add 3 to both sides, we get x equals 3. We get the same root twice, which I'm getting ahead of myself, but that means that we have a double root. And you don't have to know that right now. But I just want to point it out. We've got the same number twice, which is where I call that the double root. But ultimately what we're working on here is we're working on solving by factoring. And something that's really important when we solve by factoring is the equation must be set equal to 0. If it's not set equal to 0, then we need to rewrite it so that it's set equal to 0. So when we look at 4a here, we need to rewrite this equation so that it's set equal to 0. So we're going to subtract 9 from both sides. And we get 5x squared plus 12x minus 9 equals 0. Again, the equation must be set equal to 0 to use this technique. And once again, what we're going to see, like we've seen on most of our factoring problems so far, is that we need to split the middle. So our A is 5 and our C is 9, and 5 times 9 is 45. So our factors of 45 are 1 and 45, 3 and 15, and 5 and 9. Will any of those combine to be 12, Tiffany? Which one?
15.
3 and 15. You know what the signs are, Tiffany?
Negative 3.
Negative 3, positive 15. So when we put these back into the problem once again, here's our 5x squared. Here's our minus 9. Do you want me to write down the 15x first or the minus 3x first? And it doesn't make any difference to me. Positive 15x, okay. Again, it does not make any difference, our order here. But we are going to group. And we should end up with the same factors in the end. So when we look at our first group here, the GCF between 5x squared and 15x, well, the biggest number that goes into both 5 and 15 is 5. But we also have, between x squared and x, the smallest exponent of an x. 5x squared divided by 5x is 1x. We had 2 x's, we took out 1. We've got 1 left. 15 divided by 5 is 3. We had 1x, we took it out. Over here, in our next group, the biggest number that goes into both 3 and 9 is 3. And 3x divided by 3 is x. Negative 9 divided by negative 3 is 3. And sure enough, we've got the same factor in both groups. And that's what we want when we're splitting the middle here. We've got an x plus 3 in both groups. And then we're left with our singles, our 5x minus the 3. And remember, that equals 0. So now, what's going to happen is we need to solve. We need to use the zero product law. And what the zero product law says is that either x plus 3 equals 0, or 5x minus 3 equals 0, or they both equal 0, and we solve. And some of you will need to do less work than others. But we subtracted 3 from both sides. Over here, add 3 to both sides. We end up with 5x equals 3. And it's 5 times x. Our inverse operation says to divide by 5. And we get x equals 3/5. If you notice in the directions, because I haven't been reading them that much, it does say leave answer in simplest fraction form if necessary. It's necessary. There. Letter B. Again, when we're solving by factoring, our equation must be equal to 0. And in example B here, once again, we do not have our equation set equal to 0 yet. We can rewrite it so that it's set equal to 0. And we can start by adding 12x to both sides. We end up with 3x squared plus 10x equals 8. What we're trying to accomplish here is that we want the equation set equal to 0. So we need to subtract 8 from the other side as well. And we get 3x squared plus 10x minus 8 equals 0. Now we have it in a proper form, and in fact, we could have done grouping as well, but it looks like I'm in the split the middle zone right now. So I'll split the middle once again, and it's probably the method that we need the most practice on. RA times C. 3 times 8 is 24. And the factors of 24 are 1 in 24, 2 in 12, 3 in 8, and 4 in 6. Be careful on a problem like this, because we have two sets of factors that can combine to be 10. The 2 and 12 can combine to be 12, but the 2 and 12 can combine to be 10. The 4 and the 6 can also combine to be 10 also. So let's go ahead and put signs on here. What would the signs have to be on our 2 and our 12? Bradley? -2, positive 12. Jordan, what would they have to be on the 4 and the 6?
Positive 4 and positive 6.
Positive 4 and positive 6. Which one is going to give us a negative value over here on our constant? Tiffany? It's going to have to be this one. We need to pick one that has a negative in it because it's -8 back here in the problem. So this is not going to be the 4 and the 6. So once we determine that, our 3x squared, our -8 here. Do you want me to put the 2 first or the 12 first, and it doesn't make any difference to me? Isaac? Okay. So we're going to do plus 12x minus 2x. And again, it doesn't matter the order. We do need to have the proper signs. But 12 minus 2 gives us 10. And when we group the GCF in our first group between 3 and 12, the biggest number that goes into 3 and 12 is 3. Between x squared and x is x. So 3x squared divided by 3x is x. We had 2 x's, we took out 1. 3 divided by 3 is 1. 12 divided by 3 is 4. X divided by x is 1. In our next group, the biggest number that goes into both 2 and 8 is 2. 2x divided by 2 is x. -8 divided by -2 is 4. And once again, what we see is that we have an x plus 4 in both groups. So our x plus 4 in both groups. And then we've got 3x minus 2. But now that we've factored, we need to solve. So we're going to set each factor equal to 0 based on our zero product law. We have x plus 4 equals 0, and we have 3x minus 2 equals 0. Again, some will require less work than others. We can subtract 4 from both sides to get x equals -4. Some people might be able to go from the parentheses to the answer. I'm fine with that. Over here, add 2 to both sides. We get 3x equals 2. Divide both sides by 3. So x equals 2/3. So the thing about solving by factoring is we can use all the methods. So our last page here of notes is more practice for us in identifying which method to factor, which method to use when we factor. So when we look at problem number 5, solve each of the following quadratic equations, leave answers in simplest fraction form if necessary. Our first problem is 16x squared minus 25 equals 0. What method do we need to use to solve this problem? And again, that's sometimes what the hard part is of this. We're going to have to use the difference between two squares. One of the hints is that 16 is a perfect square. 25 is a perfect square. So if we take the square root of 16, we get 4. If we take the square root of x squared, we get x. If we take the square root of 25, difference between two squares, different signs. Now remember, we want to solve. We're going to apply the zero product law now. 4x minus 5 equals 0. 4x plus 5 equals 0. And we can add 5 to both sides. We'll get 4x equals 5. Divide both sides by 4. And again, what some of you might see is you don't necessarily need to do all the work on our second factor because the only difference is a sign. But I will do all the work. We get 4x equals negative 5 and divide both sides by 4. We get x equals negative 5/4. So we have positive 5/4, negative 5/4. Identifying the method of factoring. We can identify it. Well, before we can even identify, what do we have to start with? Well, we have to make sure that our equation is set equal to 0. So we're going to start with subtracting 24x from both sides. And we get 8x squared minus 24x equals 0. Maybe a little bit easier then to identify the method. Which is going to be GCF. So what's the GCF between 8 and 24? In other words, what's the biggest number that goes into 8 and 24? It's 8. Between x squared and x, it's our lowest exponent of x. And when we factor that out, we're left with, not that. 8 divided by 8 is 1. X squared divided by 8, x is x. We had 2 x's, we took out 1. Here comes the 3. 24 divided by 8 is 3. We can't factor anymore. And now we're going to use our zero product law. 8x equals 0. And x minus 3 equals 0. And we're going to divide both sides by 8. So we get x equals 0. And over here, add 3 to both sides. We get x equals 3. Again, identifying the methods is helpful. Problem C. X cubed minus 5x squared minus 4x plus 20. We have 4 terms in this problem. What kind of method do we use when we have 4 terms? Tiffany? We can split the middle, but it's also called grouping, and I think she knew what she meant there. Which we turn a split to middle into this grouping problem, so that's what I think she was thinking. What's the GCF of our first group? Well, it's the smallest exponent, it's x squared. And then we factor out an x squared. We had 3 x's, we took out 2, we got 1. 5x squared divided by x squared is 5. We had 2 x's, we took them both out. In our second group, what's the biggest number that goes into both 4 and 20? Well, 4 goes into both. And 4x divided by 4 is x. 20 divided by negative 4 is negative 5. And now we've got the same value in each group. We've got an x minus 5 and an x minus 5 in each group. And our single. X squared minus 4. Are we done? We can factor some more. Matthew?
Or you can make the 4 equation equation for x equals -2 -2
Square root of x squared is x and x. Square root of 4 is 2 and 2. Difference between two squares, different signs. And now, we already had it set equal to 0, but now we need to figure them out. And again, there's some of you who could tell me x equals 5, x equals 2, x equals -2. I am fine with that. If you're not one of those people, though, we're going to take x minus 5 and set it equal to 0. And we're going to take x minus 2 and set it equal to 0. And we're going to take x plus 2 and we're going to set it equal to 0. And by the way, there's not any particular order that we list our roots, our solutions, or our x-intercepts here. But you do need to have all three of them, 5 and 2 and -2. As we finish, one last time, we must have the equation set equal to 0 to use the zero product property. That means that we're going to have to add 7 to both sides. The nice part on this one is that they're all pluses. So whenever I see all pluses, we don't have to worry about signs so much. But this one is definitely split the middle problem. Our A value is 4. Our C value is 7. And 4 times 7 is 28. So we have 1 times 28, 2 and 14, 4 and 7. Will any of those ever combine to be 16? Jordan?
2 and 14.
2 and 14, we're going to add them together. And in a minute, once I get this written down here, do you want to put 2 first back in our problem, or 14 first back in our problem? And it doesn't make any difference to me. Isaac? 2 first. So plus 2x plus 14x. And it doesn't matter. If you wrote 14x first plus 2x second, that is fine. It will still work out just fine. So when we look at this then, the GCF in our first group between 4 and 2 is 2. Between x squared and x is x. 4 divided by 2 is 2. X squared divided by x is x. We had 2 x's, we took out 1. And here's the thing. 2x divided by 2x is 1. We must write the 1. Over here in our second group, between 14 and 7. What's the biggest number that goes into 14 and 7? 7. Well, 14 divided by 7 is 2x. 7 divided by 7 is 1. We have to write it. So now, we get close to finishing here. From each group, we have 2x plus 1. Then our single, 2x plus 7. And we're going to use our zero product property, which says that we're going to set each of those factors equal to 0. It's either 2x plus 1 equals 0, or 2x plus 7 equals 0, or they both do. We're going to subtract 1 from both sides. We get 2x equals -1. Divide both sides by 2. Over here, 2x equals -7. X equals -7 halves.